Morning folks, 10th of April, let's go! So, Foundation Plus starts off with a topic we haven't seen yet, which is trial by improvement, or trial and improvement. It tells you that you've got a volume is 1050, it also tells you that the volume is x cubed plus 4x squared, so obviously your first thought is let's set those two things equal to each other. But we can't solve that, because there isn't a way to solve cubic equations quite that easily. Certainly not at GCSE. So this is one where you try stuff out. We're trying to find the value of x to one decimal place. So we'll try some numbers and try and get as close as we can to 1050. So I'll put down like my little values of x, and then what x cubed plus 4x squared is for them, and then is that too high or too low compared to 1050. So I started with 2, that was way too low, 5, 8, 9 was really close. But because we want this to one decimal place, we have to check the next one down. So we had to check 8.9 and then the one in the middle, so 8.95. And the one that it is the odd one out, basically, our one high to our two lows. To be honest, you could probably look at 1053 and 1021 and think, well, it's going to be closer to this one. But that's the check you need to do. Okay. Next up, we've got a couple of nice factorisings. First one just adds to 14, times this to 48, that's 6 and 8. The second one, that's another difference of two squares. You will notice they really like these. 3y this time is the square root of 9y squared, so 3y plus 1, 3y minus 1. Next one, a single power of y, so we have a multiplication inside the bracket, so we'll do that first. 5 plus 6 is y11, and then bracket to a bracket means multiply, so 11 times 2, y to the power of 22. Next one, so we have this set up here. We want to find the size of y over here. So we need to use parallel lines, so that's either alternate, corresponding, or supplementary. So alternate is your old Z shape, corresponding is your F shape, and supplementary is your C shape. These two are the same, these two add up to 180. Anyway, in this case we have a Z shape. So we have an alternate angle that gives 154 here. And then we've got an isosceles triangle because of these two lines here. So this means these are both 13 because they all have to add up to 180. And then y is on a straight line with the 13, so take that away from 180 and get y is 167. So the reasons for that was an alternate angle, then an isosceles triangle, then a straight line. Okay, so moving on to higher. We have an inverse proportion question to start with. Here we've got inversely proportional to the cube of x, so that means specifically that we're dealing with x cubed. And it's got y is 4 and x is 2, so we'll put in y is 4 and x cubed is 2 cubed is 8. And because it's inversely proportional, that's where we have 3 lines on our grid, they are timesing to 32. So y when x is 1, well, if x is 1, then x cubed is also 1, and they still have to times to 32, so y is now 32. Job done. The formula, for what it's worth, will be y equals 32 over x cubed. Doesn't want that, but it might do. Vector AB, we go minus b to take us to O, plus a to take us to b. This one looked a bit more complicated than it is. It's essentially a 3D Pythagoras question. There is a right angle here, but there's a nice little shortcut with 3D Pythagoras, which is that if you're always moving at right angles, you can just have it as one big Pythagoras. So we could, work out this distance first and then work out this distance, but it's actually easier to go 10 squared plus 9 squared plus 4 squared takes us to here, and then that's x squared. So I did 9 squared and 10 squared and 4 squared, 197, square root that, you get out 40.05 or something. Okay, moving on. Simplify algebraic fraction, you always want to factorise first in these scenarios. The top one, plus 4 and plus 6. The bottom one, plus 6 and minus 6. Again, it's a difference of two squares. And if you've done it right, two of them will cancel out. In this case, it's the x plus 6, and that leaves us with x plus 4 over x minus 6. Lastly, this is a non-calculator question, because on a calculator question, it would be simply just typing in 19 root 5 and seeing if it's bigger or less than 40. So if this was a non-calculator question, we need to compare these two things directly. And root 5 is awkward because root 5 is like 2.2, it's a horrible decimal. So we want to try and put them backwards into real numbers. And what I'm going to do here is I'm going to change the whole numbers into roots. So for example, I could say 2 was the square root of 4. I could convert between those two. Now the ones that we're looking at here are 19 and 40. And in theory, in the GCSE, you're supposed to know 19 squared is 361, or at least be able to work it out. So that would tell you that 19 is the square root of 361. So instead of saying 19 root 5, I could say this is root 361 times root 5. I can multiply those two things together, because surds can do that, and say this is overall root 1805. I can do the same thing with 40. 40 squared is a little bit easier, is 1600. So 40 is the square root of 1600, and I can compare those two, and I can see that the amount of ribbon we need is root 1805, and the amount of ribbon we've got is this. It's clearly less, so I shouldn't have said yes there. No, we do not have enough ribbon. Okay, moving on. Now higher plus was fairly tricky this week, these 2 days. We're starting off with pressure. Now in theory I thought this was going to be a pressure triangle. You've got pressure, force and area, or pressure, weight and area apparently in this time. But it's actually not. It's more about converting units, which is why they're giving you these unit conversions here. It says 32 pounds per square inch. We want to change this to grams per square centimetre. So kind of like when you're doing meters per second and kilometers per hour, write them out as like a fraction. 32 pounds per inch, write 32 pounds over 1 square inch. And then use the conversions we're given. So we're told 1 pound is 0.43536, so we'll multiply 32 pounds by that to get it into kilograms on the top, 14.5 odd kilos. And then this is the one you've got to be careful of. 1 square inch is 2.54 squared centimeters squared. If the unit is squared, you need to square the conversion as well. So we'll end up with 14.5152 kilos over 6.4516 centimeters squared. That's still not quite there because we want grams, we don't want kilograms. And if we want to get from grams to kilograms to grams, we times by 1,000. So that would go up to 14,515 grams over your centimetre squared. And then we can divide that through and say this is 2,249.9 grams per centimetre squared. So yeah, fairly fiddly unit conversion, that one. And the fiddliness is not done yet, because we have this one, which is horrendous. So we have got here x plus a all squared times x minus 2 is equal to this, and it wants us to find a and b. And I can't think of any other way of doing this than working out what the left-hand side expands to, as simple as we can make it. So it starts off with x plus a squared. So I worked out what x plus a squared was, and got it was x squared plus 2ax plus a squared. And then I need to times that by x minus 2. So you can do this with a grid, actually is another way of doing it, but I did it using just multiply everything on the left by everything on the right. Ended up with this horrible little mess. And then I wanted to sort of combine it together. So obviously I've just got x cubed, so that's just x cubed. And then I look for the things that have x squared in front of them. I've got 2ax squared here, and I've got minus 2x squared here. So overall I have 2a minus 2, lots of x squared. I have a squared x here, minus 4ax here, so overall I've got a squared minus 4a, lots of x. And finally I've got minus 2a squared. And I was thinking that this is quite a lot of work, but it actually did end up being required for this question. I've got a feeling if it was a GCSE one, they'd sort of handhold you through it a little bit. So what I can do is I can directly compare things. So I've got x cubed, and that's the same as x cubed, okay? No great things there. Then look at the other thing. So I've got 2a squared is the same as 72. And those are the things I've underlined in red there. So I can say those things are the same. I can divide by 2, I can square root, and I could either have 6 or minus 6. Don't know which one of those is right yet, to be fair. It could be both of them, or it could be just one. I need to compare the other things, so I can say this 12 here is the same as this a squared minus 4a, because that's both the amount of x we've got. So I can say a squared minus 4a is 12. I can take away the 12, because to solve any quadratic you need one side to be 0. And then I can factorise that and solve it, and I can get a is 6 or a is minus 2. Now, A has to be consistent, so the only one that's true for both of those is 6. So we say A is 6. And then finally, we can say B is 2A minus 2. We'll use the 6 that we've got and get that B is 10. This is called comparing coefficients, and it's a fairly advanced technique for seeing what different values are in these sort of identities. But A is 6 and B is 10. Could not think of a different way of doing that. If you do, let me know. Then we've got the area of a segment. Now that's this green shaded area here. And to find the area of a segment, you do the area of a sector, so that's the whole circly bit, take away the area of the triangle, because that's obviously what's been removed. Now a sector, we should know, x over 360 times pi r squared. Triangle, half AB sine c. So we've got our A is 4, our B is 4 as well, and our sine c is sine 145. Once you've got that, you can just type it all in, work it out, 15.66 centimeters squared. But you've got to know those formulas to start with. And then finally, no, not finally, and then next we had a tree diagram question. So it says 2 students are selected at random, find the probability they study different subjects. Now, different subjects is either French and German or German and French. It doesn't say they're replaced, so we do have to change the probabilities once we picked one. So I did tree diagram, French and German. There were 18 French and 32 German. It didn't seem to matter whether they were boys or girls, so we can ignore that. 18 out of 50 and 32 out of 50. If you've picked a French speaker, then there are 32 German speakers left out of 49. If you pick the German speaker, there are 18 out of 49 French speakers left, and so on. To get these probabilities, you multiply across. So this was 18 over 50 times 32 over 49, just times the top by the top and the bottom by the bottom, and then add them together because they're both situations where students study different subjects, and then as a decimal that's 0.47 if you wanted it as a decimal. Okay, and then our final one, and there's a complicated way of doing this and an easy way. I'm probably going to end up recommending the easy way, but it's worth talking about them both. The first 4 terms of a sequence are these things. What is the first negative term? Now the easy way is to write out the sequence. You can see I've done that on the bottom here, and I've just kept going until I get to a negative number. I can tell it's going down by 10, then 15, then 20. It's going down by 5 more each time. So I did it. I went down by 10, 15, 20, 25, 30, and so on, until I got to my negative answer, which was the 18th term. So that would be fine. The more algebraic way of doing this would be to work out what the quadratic sequence actually was, because this is a quadratic sequence because the second difference is the same. And it's worth recapping how you do this either way. So the second difference ends up being minus 5, because it's decreasing the amount it's going down by. So our A is half of that, is minus 2.5. Our 0 term ends up being 805, so our plus 805 goes on the end. And then these 3 numbers need to add up to the first term, need to add up to 800. So I've got 800 minus 2.5, that's 802.5. Take away another 2.5, takes me to 800. So that's my sequence. And then I wanted to rearrange this because I really didn't want to solve this. So I moved all the n stuff across to the right, added 2.5n squared, added 2.5n, and divided everything by 2.5. So I got 322 is n squared plus n. And then I used what we did right at the start of today. I used some trial and error to work out when this happened. When was the first time that n squared plus n was bigger than 322? And I got that it happened on the 18th, when n was 18. So, yeah, that was another way of doing it. It got you to n equals 18. There was possibly an even more complicated way around this. It involved solving a quadratic inequality, but nah, not this time in the morning. So yeah, cheers. That's the penultimate day. See you tomorrow.